Example 8. Write the linear approximation for the equation f of x equals 1 over x minus 1 at x equals negative 1, and then use that equation, to find the approximation of f of negative 1.2. All right, so here we go. All right, so the first thing we need to do, let's go green. All right, so the first thing, I'm going to rewrite f of x as, I'm not going to do quotient rule whenever the constant, you have a constant numerator. So I'm going to call this x minus 1 to the negative 1. All right, so then f prime, what can you do? So it's negative 1, x minus 1 to the negative 2, okay, which is also negative 1 over x minus 1 squared. And of course, to find the line that's going to represent at that particular moment, I need a couple of things. I need f of negative 1, but f of negative 1 is going to be negative 1/2. Okay, cool. And then I need f prime of negative 1. And so if I place a negative 1 in here, negative 1 minus 1 is negative 2 squared. That'll be negative 1/4. There we are. All right, so our line, I'll put that right here. Our line would be y minus y1, which would be plus 1/2, equals negative 1/4, and then x plus 1. Perfect. Okay, so then if you like, using the notation that we used earlier, that'll be fine. That means that f of x can be approximated using the line negative 1/2 x, negative 1/2 minus 1/4, and then x plus 1. It's all the same stuff, but just a different way of writing it. And I like this because you get to use the approximation thing, and then you've got a function there. And so then you could say, all right, then f of negative 1.2 would be about equal to L of negative 1.2. Okay, I know I got a mixture of fractions and decimals here. We'll go with one of them here in a second. So that'll be negative 1/2. Okay, minus 1/4 of negative 1.2 plus 1. All right, and so that is equal to negative 1/2 minus 1/4 of, and this is going to be negative 0.2, which is negative 1/5. So I'm going to write that as negative 1/5. Very nice. Which is, all right, so that'll be adding a 20th to negative 1/2. So I'll think of negative 1/2 as negative 10/20. And then I'm going to be adding 1/20 to that. There you go. And that'll be negative 9/20. And if you do the decimal, what is that? Negative 0.45. All right, so negative 0.45 would be perfectly fine. All right, so then calculating the error then, so the error is going to be the absolute value of the actual function value. So f of, and I'm going to use the calculator on this part, f of negative 1.2. And it doesn't matter which one you put first. I typically just put that one first. And then your approximation at negative 1.2, which we just found. Okay, and so let's break out the calculator here and let's do these two. And so if you actually want to have the absolute value this time, you can always go math. It's number, go over, and absolute value is the very first one. And so f of negative 1.2 is, let's do pretty fractions. No, let's have it a decimal. All right, I changed my mind on that. So we're going to have 1 over negative 1.2 minus 1. Okay. And then minus L of negative 1.2, which we just found to be negative 9/20. So that's going to be minus a negative 9/20. And then there we are. Okay. So this error in the approximation at this point is very small. I mean, relatively small, I guess. So it's 0.00455. All right. So then you could say, all right, so the error, depending on which way you're looking at it, absolute value of the error all right, is less than 10 to the negative 2. One day it'll do it. And there we go. All right, so there's number 8. Yay, 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 yay.